All right, everybody, we are back with 11.7. This is volume of cylinders, cones, and spheres. Spheres are the easiest. I'm sure they'll put them last. Cylinders and cones probably coming up first. All right, so let's see here. Okay, here is the volume formula. Now, again, that B is the area of the base, or in this case, being a cylinder, both circles. So it's pi r squared for the area of the circle on the top and the area of the circle on the bottom. So if you're wondering why there's a B here and it's a pi r squared here, that's because its base is a circle. And the H, of course, is the height of the cylinder. And you guys, one more time, that is the length that runs from one base to the other base. In this case, it's the length that runs from the circle on the top to the circle on the bottom. And you can have obliques, so I'm sure they'll talk about that here in a second. All right, example number 1. Okay, approximate the volume of a cylinder. All right, Postal Service. Andrew wants to mail his brother a collection of antique marbles. He needs to calculate the volume of the mail tube before he buys it to ensure that it will hold all of the marbles. Find the volume of the mail tube to the nearest tenth. Well, okay. So first off, make sure that you realize that if the line goes all the way across, that is a diameter, my lovely people. That is not the radius. So, oh my gosh, they made another typo. People, you guys are killing me. Y'all are supposed to be again smarter than me, and yeah, that line clearly goes all the way across. 1.25 is the diameter. Okay, so yeah, wrong. Do y'all not have people that check behind y'all? Okay, and I'm sorry I'm saying this out loud, but come on, let's get it together, y'all. All right, so 1.25 is the diameter. That line goes all the way across. That means you got to divide by 2 to get your radius. So this is a typo. Typo, people, typo. 1.25 divided by 2 is 0.625. That is the radius, not 1.25. So 0.625, y'all. That's your radius. That's the number you're going to square and multiply times pi, and then times 10 for the height of the tube, the height of the cylinder. Okay, so yeah, watch out for that. So it should be pi, and then times 0.625 to the power of 2, and then times the 10. So I just want to make sure you guys get that. All right, so it's approximately 12.27. If you're a teacher like me and you want your students to get used to the way they're going to see it on the ACT, and that is in terms of pi, that's a lovely thing, you guys. And there's nothing wrong with that. I prefer my answers in terms of pi just so I can get my students ready for the way they're going to see it on the ACT. And of course, if they take calculus, eventually they're going to want to have things in terms of pi. Nothing wrong with that. So you should be looking at 125 pi over 32, because that's the way I would have left it. All right. So let's see. So again, this is wrong. 49.1 is not the correct answer. So please, please, please keep that in mind. Not the right answer, because somebody clearly did not do their homework. All right, example 2. Volume of a cylinder. Okay, so here's a great example of radius. There is a line that does not go all the way across. It is at the center of the circle out to the edge of the circle, on the circle itself. So it'd be x minus 5. That's your radius, y'all. That's your radius. Diameter when the line goes all the way across. All right. So I don't want my students to be confused, so I'm making a big deal about that because clearly somebody did not do their homework. All right, so we see we got pi r squared. So we need to square the x minus 5, and that's why there's a power of 2 right there. And then the x is the height of the cylinder. Okay. Oh, they didn't do it. Okay. They just left it like that. Okay, so basically they did example number 2 for us. Okay, well, my work here is done. Oh, part B, they want us to do a little plugging and chugging. Fine. I'm going to take that X out, replace it with an 8. Take that x out, replace it with an 8. So it'll be 8 minus 5 is 3. Squared is 9. 9 times 8 is 72. So it'll be 72 pi. 72 pi. Actually, let me do the pi symbol. Or 226.19. And sorry, 226.19. And that's cubic centimeters. 72 pi is what I prefer if you're my student. All right, moving on. Okay, volume of cones. Okay, so they're probably going through why it's a 1/3. Y'all, there's a great video. It looks like it's a middle school group of kids. Now, I couldn't tell you where it's from, but I show it in my classroom all the time, where they have popcorn, and they've got a cylinder and they've got a cone that are the same radius shape, and they fill it with popcorn. They fill the cone with popcorn, and it shows that it takes 3 cones to fill up a full cylinder for the same height and the same radius. It's a great little demonstration video. I show it in my class every year when we get into volume. All right, so 1/3. All right, height, there's your true height. And if it's oblique, there's your true height. Remember, we don't go with slant. So if they, for whatever reason, give you the slant of this cone, you're going to do the Pythagorean theorem, that right triangle right there, to find the true height. All right, let's get into it. Enough talk, more action. Example number 3. All right, we got to find the volume of cone, 1/3 pi r squared times h. Okay, so there's my radius, x minus 1. So that's what's the square there, is that's my radius. The height is the true height, 3x minus 5. That's what's going to go in for the h. And, okay, looks like they did this example for me. Nothing to do here. They leave it just like this. All right, fine. Example 3, done. Woo-woo! All right, we got to do a little plugging and chugging with a 4. So every time you see an x, replace it with a 4. So 4 minus 1 is 3. 3 squared is 9. 1/3 of that would be 3. That goes back to being 3. All right, 3 times 4 is 12. 12 minus 5 is 7. All right, 7 times 3 would be 21 pi. Yeah, 21 pi. Or, let's see, that would be approximately 65.97 cubic feet. All right, so again, I prefer the pi's to be 21 pi, 65.97 cubic feet. Okay, moving on. Example number 4. All right, we got to find the volume of this cone, and there it is right there, Pythagorean theorem. We need to find the true height because 15 is the slant. And when I take a 10, because that's my diameter, and divide by 2 to get my radius, I get a 5. Okay, so we need the Pythagorean theorem with 5, the height, and 15. So a squared plus b squared equals c squared. 5 squared plus the height squared is 15 squared, because that's our hypotenuse. All right, you're going to subtract 5 squared to the other side. 15 squared minus 5 squared is 200. And the opposite of squaring that is to square root the 200. Do they leave it just like that? Really? See, I would have taught my students to simplify that. But they don't, strangely enough. ACT is going to have that simplified, y'all. So that's going to be, 100 times 2. And the square root of 100 is a 10. So it'll be 10 square root of 2. You're going to have it 10 square root of 2. Maybe later on they're going to, I don't know, simplify it. No, they're going to leave it as a decimal. I hate people like y'all. Y'all are killing me. All right, so volume, 1/3. Pi r squared times the square root of 200, which is 10 squared root of 2. All right, if you're wondering where I got the 5, don't forget the radius is from the center all the way to the edge, so that'd be 5. When it goes all the way across, that's your diameter. Take 10 divided by 2 is 5. All right, so 5 squared is 25. And then times your square root of 200 times pi. Divide that all by 3. And they're going to want a decimal here. Okay, so the decimal 370.24. And that is cubic centimeters. All right. So cubic centimeters, y'all, 370.24. All right. So let's see. Personally, I would have left it times 10. I would have left it with a pi in there. So let's see, 25. Oh, my now my calculator decides not to work anymore. Well, forget that. Let's move on. All right, got to check. Okay, let's see here. Soap dispenser can be modeled with a cone. The height is 15 centimeters. The radius is 4. What's the approximate volume? Okay, so no Pythagorean theorem here. They give me everything I need. So I need to do 1/3. Okay, and then times pi r squared, and they tell me the radius is 4, so times 4 squared. And then times the height of the cone, which is 15. Okay, so 4 squared is 16 times 15. 16 times 15. Let's see, that's going to be divided by 3. And then stick a pi, be 80 pi. Yeah, be 80 pi. Or, let's see, the calculator, so it'd be 251.33. So there it is. Volume. 251 point, come on, 0.33 cubic centimeters. All right. Okay, so you need a couple examples. Go online. Maybe your teachers are going to give it to you. All right. Spheres, the easiest. I love spheres. They're so easy. If you know the radius, that's really all you need. If they give you the diameter, make sure you divide by 2 to get your radius. But the formula is 4/3 pi r cubed. So expect big numbers, students. Expect big numbers. And if you're a new teacher, expect them to not understand that it's going to be big numbers. Because anytime you cube a number, you're going to get a big number. You're multiplying it times itself 3 times. All right, so 4/3 pi r cubed, everybody. That is your formula. And we are on example number 5. All right, a chocolate company wants to create bite-sized, individually wrapped, solid chocolate spheres. If the diameter of the sphere is 1.5, don't forget to divide by the 2. Find the volume of the chocolate used to make the spheres to the nearest hundredth. All right, 1.5 is my diameter. Divide by 2. That will be my radius. So to be 0.7, come on, 0.75 to the power of 3. All right, so cube that, everybody, in your calculator, multiply by 4/3, and then times pi. And it'll be approximately, okay, 1.77 cubic inches. If you're going to leave that in terms of pi, that would be 9 pi over 16. Yes, 9 pi over 16. 9 pi divided by 16, which is approximately 1.77 cubic inches. I love spheres. Spheres are easy. All right, example number 6. Okay, let's see. We got to examine the sphere. Got to find the volume in terms of x and pi. Okay, I notice my line is a radius line, not a diameter, because it only goes to the center. So r is 2x plus 3. That's what you're going to cube. And thank the Lord above, they did not actually have us do that. Because that would have been 2x plus 3 times 2x plus 3 times 2x plus 3. Yeah. Foil method and another foil. So anyway. All right, so they leave it alone. So it's 4/3 pi 2x plus 3 to the power of 3. Okay, they actually did it out for us. There you go. There's its ugly real answer. I was hoping they would not make me do that, and they did not. All right, but part B, they want me to do a little plugging and chugging with the 2.2. So every time I see an X, 2.2 goes right there. So it'll be 2.2. All right, times 2, and then plus 3 to the power of 3 times 4/3 times pi. All right, good grief. 1,697.40 cubic inches. Again, that's 1,697.40 cubic inches. All right, there you go. Example number 6. Is that the last one? No, just when you thought. Example number 7. Looks like we got a composite. We got a cone sitting on top. Ooh, a hemisphere. All right, so when you find that volume of the sphere, everybody, divide by 2. Because it's not a full sphere, it's a half of sphere. So 1/2 times 4/3 pi r cubed. Watch out for that, everybody. And if you're a new teacher, make sure you understand that they will forget that. Make sure they look at that for that first. So it's 1/2 4/3 pi r cubed. All right, what do they do first? They want us to find the volume of the cone. Okay, lovely. They gave us the true height, and 8 is our radius. So no trick there. 8 squared times 17 for the height. Don't forget your 1/3, and then pi. All right, so it looks like the volume of the cone itself is 362, and it's a repeating 6, so it'll be 2/3. And again, this is the cone itself, because 8 squared is 64 times 17, then divide that by 3. Don't forget your pi. I mean, if you leave it in terms of pi, it'd be 1,088 pi over 3. 1,088 pi over 3. All right, 362 point repeating 6. And that is cubic millimeters. All right, now we need to find the hemisphere. Okay, don't forget it's 1/2, because it's not a full sphere, it's a half a sphere of the 4/3 pi r cubed. 8 is the radius. All right, it looks like they went ahead and multiplied 1/2 times 4/3. That's nice. So it'll be 2/3. 8 to the power of 3. All right, so that's 8 times 8 times 8 times the 2/3, and that's going to be 1,024 thirds. So if you're leaving it in terms of pi, that would be at 1,024 pi over 3 multiplied by pi. All right, so we got 341 and a repeating 3. All right, 341 and 1/3. All right, now to add those together, to get a composite, be 704 cubic millimeters. 704 when you add the volume of the cone and the volume of the hemisphere together. Okay. Oh, we got to check here. Got to check. All right. Okay, we have a cylinder in between a sphere. Okay, because you got a hemisphere on the left and a hemisphere on the right, which means you have a sphere. So we're going to find the volume of the cylinder, because I see double circles. All right, and I'm going to find the volume of the sphere and add them together. Okay, here we go. All right, so 12 is your radius of the circle. 8 is the height of the cylinder. All right, so we'll do the cylinder first. All right, so this is for the cylinder. Let me go ahead and make sure you guys understand that. All right, so the volume of a cylinder is pi r squared h. Pi 12 squared times h. That's the 8. Okay, so we've got 12 squared, 2044 times 8. Okay, that's going to be 1,152 pi. Now, I'm leaving it in terms of pi. This is the volume of the cylinder. Okay, sphere. The volume of a sphere is 4/3 pi, and then r to the power of 3. Again, you guys expect a big number. I mean, 12 to the third power alone is huge. Multiply it by 4/3, you get 2,304 pi. And again, this is the volume of the sphere. Okay, take the volume of the cylinder, add it to the volume of the sphere, you get a total of the volume of the composite, 3,456 pi. There it is. Total volume. I should say total. Yeah, there we go. All right, total 3,456 pi. And that is cubic centimeters. 3,456 pi. All right. Oh, okay. Example number 8. Got home decor. Mia purchased a trash container for her study area. Find the volume of the trash container rounded to the nearest tenth. Okay, well, we've got a cylinder here. We've got a hemisphere. It's not a true cylinder. How do they want me to do this? Oh, okay. They're just asking me how I'd approach it. Okay, great. Okay, so that do they actually want me to find? Well, you know what? I'm getting ahead of myself. Let's do this. Well, it says find the volume. Oh, yeah, they want me to round to the nearest tenth. Okay, here we go. Describe the task in your own words, then list any questions you might have. Find the nearest. Okay, describe the task in my own words. Well, first I'm going to find the volume of this cylinder. And the formula is pi r squared h. Find volume of cylinder and volume of a hemisphere. How am I going to approach it? Well, I'm going to use 1 for the radius, because 2 divided by 2 is 1, and 4 for the height. That means up here for the hemisphere, I'll use 1 for the radius again. Okay, so use r equals 1, h equals 4. For the cylinder, and apparently I can't spell, r equals 1 for the hemisphere. How about with a C? Okay, what's some solution? It's the volume of the bottom portion of the container in terms of pi. Okay, so, well, let's see. 1 squared is 1, so it'll be 1 pi. 1 pi. Volume of the top portion of the container in terms of pi. Well, 1 pi. Even though it's not really. They're different. Alright, what's the volume of the trash container of the top portion of the container? Oh, hang on, volume of the top portion. Oh, okay, my bad. Whoa, back up. Woo. I misunderstood the question. What's the volume of the bottom portions? This is the volume of the cylinder. Okay, so 1 squared is 1 times 4 is 4, so it'll be 4 pi. All right, here they want the volume of the hemisphere, so it'll be 1/2 of 4/3, so it's 2/3. Times pi times 1 to the power of 3. 1 to the power of 3 is 1. Times 2/3 be 2/3 pi. Okay. Add them together. So 4 pi plus 2/3 pi. That is going to be 14/3. 14/3 with a pi. All right. Bet your solution is reasonable. You need to defend your solution. I ain't gonna argue nothing. I'm that good. Well, I understand what they're saying because this is clearly smaller at the bottom than it is on the top. But this is an estimate. This is not a real because this height's slanted. It's not true height. And this is a wide circular base than this one. So it's just estimate, people. Let's just go with it. All right, let's move on. Oh, hey, I'm not moving on. Practice is all you. All right, have any questions, ask me or ask your teacher. You guys have a great one.